In today's lesson, we're going to look at section 10.2, where we translate and reflect our trigonometric graphs. There are 3 learning targets for this section. Learning target 10.2a is I can graph vertical and horizontal translations of trigonometric functions. Learning target 10.2b is I can graph a reflection with a translation of a trigonometric function. And learning target 10.2c is I can write trigonometric equations from given transformations. In today's lesson, we look at the translations of our trigonometric functions. We're going to focus first on our sines and cosines graph. So we're going to now have new values that we put in with the sine and cosine. In the section 10.1, we looked at graphs of sines and cosines, and when the amplitude and the period maybe changed, so there were a and b values. Now we're going to add in some h and k values into our graph. So the 2 general functions that we'll be using is y equals a sine of b times the quantity x minus h, and then plus k on the outside of that trig function. So that k value is not with the trig function, it's on the outside of that trig function. And then also our cosine function, which is the same thing but with a cosine, so y equals a times the cosine of b times the quantity x minus h plus k. Now keep in mind the a and the b are still there from what we did yesterday, so the a still affects the amplitude, the b still affects the period. So the new things we'll be looking at today is that h and the k value. So let's start with that k value, the value that is outside our trig functions. The k value represents what we call a vertical shift. So that is when we take and shift the graph either up or down. And to tell whether you're going up or down, it depends on whether you're adding or subtracting the k. So if k is being added, so if I have plus k at the end of my equation, or even out front, if it's a positive number being added to that sign, then it's going up. If it's a minus or it's a negative number out front, so if I have a negative k, then that means that I'm getting the graph and it's shifting down. So the k value affects whether it's going up or whether it's going down. Now the h value is a horizontal shift. So then that means either to the left or to the right. So it's taking that original function that we looked at in 10.1 and shifting it either to the left or to the right. So now to tell whether it's going left or right, because it's inside of a quantity, to the left will always be if you're adding the h value, and then the right is if you're subtracting that h value. Because remember, anytime something is within parentheses in math, to pull it out, we've got to do the opposite of it. So that's why left looks like a plus inside of there, and right looks like a minus inside of that general function. So now when graphing, there's a few steps that we need to go through when graphing any type of translations of the sine and cosine graphs. First thing you want to do is identify all those key points or key things that are going on within the graph. So things like the amplitude, which remember is just the a value, the period, which is 2 pi divided by the b value, the horizontal shift, which is the h, and the vertical shift, which is the k. These 4 things will help us get the correct graph or help us graph our function if we identify those first. After you've identified those key characteristics of the graph, the next thing to do is to draw that horizontal line, the y equals k. So if there is a vertical shift, you want to make sure that you draw that line where that vertical shift is at. And we always make it a dashed line because it's not actually part of the graph. It just helps in aiding us to graph our trig function. We also now call that the midline because that is the line that the sine or cosine graph is going to kind of oscillate above and below or go above and below. It's no longer the x-axis, it's wherever that k value was. So if k happened to be 0, we wouldn't have shifted it anywhere, so that midline would stay at the x-axis. But a lot of times there is going to be a k value, so you're either shifting the graph up or down, and so you'll have that new midline. So we just use a dashed line to show that we do have a new line that we're centering the graph around. The next step is to now find those 5 key points. So the 5 key points that we looked at in 10.1. So with the sine, it's the one that started at the x-axis or started at your midline, went up to the amplitude, back down to the middle line, down to the minimum, and then back up to the midline. And then in the cosine, it started up at the high point or up at the amplitude, back down to the middle, all the way down to the minimum, back up to the middle, and all the way back up the top. So the sine curve was kind of like a hill and a valley, whereas the cosine was just one big valley. So it's saying take those 5 key points and now translate them according to your h and your k. So horizontally, h units, and vertically, k units. Then our final step when graphing these translated trig functions is to draw the graph through those 5 key translated points. So those 5 points that we just found and then translated, we're going to go ahead and connect them to make that first cycle of either the sine or the cosine. So now remember, the only thing I require is that you make that very first cycle of the sine or the cosine curve. So now let's look at an example where we use this translation either vertically or horizontally. So they want us, and this is learning target 10.2a, being able to translate a graph or graph something that has a vertical and horizontal translation. So this one says to graph y equals 1/2 cosine of 2x minus 2. So that's a minus sign there. So minus 2. So the first thing we want to do, the first step, is to identify the amplitude, the period, the horizontal shift, and the vertical shift. So the period, just like in 10.1, we always look at the number in front of the trig function that's attached right out front, the coefficient of that trig function. In this case, it's 1/2. Remember, amplitude is always positive, so that happened to be negative out there, we'd make it positive. So the amplitude is 1/2 in this problem. The period then is 2 pi divided by, so 2 pi divided by the b value. The b value is what is in front of our variables, in this case, a 2. So it's 2 pi divided by 2. So in this case, the 2's cancel, giving me a period of pi. The horizontal shift then is your left and your right, or what's with the x value being directly added to the x or subtracted within that trig function. So in this case, there's nothing added or subtracted from the x that is within the cosine. So for horizontal shift, we're just going to put none. Vertical then is what is getting shifted either up or down. So this is a thing that is not got any cosine with it. It's not being multiplied by any cosine or sine, so any trig value. So in this case, it's that -2. So that tells me then, since it's -2, that my vertical shift is going to be down 2. So I'm going to go ahead and make my graph, keeping in mind that the reason we do this is just to get a kind of visual picture in our mind of what it looks like. Since I had a vertical shift of down 2, I know that my graph is going to have to start down 2. So I'm going to maybe draw my graph so that I see more of the negative part of the y-axis as the positive, since I do know that I have to shift down 2. So if I shift down 2, then I'm going to be right there at -2. And this is where we go ahead and draw in that midline just so we know what we're centering our graph around. And then the next thing we need to do is put in our 5 key points. Because there is no horizontal shift, I know that I'm not moving off 0, so my first initial point is still that 0's at 0. Then I'm going to make, so I can make my 5 key points. The last one being the period, so in this case, pi. And then to figure out the other ones, if I go right in the middle, that one is going to be pi over 2. Then the next one would be pi over 4. And then 3 pi over 4 would be that third one. So now what I need to do is go ahead and put my points on here. I'm going to change colors here so we can see it maybe a little better. So initially, before the shift, if this was a cosine, cosine would have started up at the amplitude. So it would have started up at 1/2. But because we're shifting it down to, I'm going up a half off of that center line. So I'm going to have a dot about right there. Then I went back to the center line. So at my next key point, I'm back at the center line. The next one, I'm down at my amplitude. Then I'm back up at the center line. And then I'm back up at my highest. And then the final thing we do is go ahead and connect those because there was no horizontal shift, so I don't have to worry about moving those points after I make them on the graph. So there is my graph of y equals 1/2 cosine of 2x minus 2, where it's taking that graph and shifting it down 2 units. Let's now look at a second example. This one says to graph y equals 2 sine of 1/2 times the quantity x minus 4 pi. So again, the first place that we start is identifying all the key characteristics. So my amplitude is the coefficient of our trig function, so in this case it's 2. Keeping in mind that if it was negative, then amplitude is always positive. Next is the period. It is a sine function, so it is going to be 2 pi divided by the b value, or what comes directly after our trig function, but in front of the variable. So in this case, it's the half, so it's going to be 2 pi divided by a half. So if I do my leave, change, flip, I actually get 2 pi times 2, which would equal, let me fix that too. So times 2, which would give me 4 pi. So my period of this graph is 4 pi. Next, I need to identify my horizontal shift, which is if it gets moved left or right any, and that's what's found on the inside of the trig function with the x value. So in this case, it's, horizontal is always what you're adding or subtracting from the x value, whereas the period was what you were multiplying by the x value. So that may help you distinguish between which one goes with your period and which one goes with the horizontal shift. So if I look at this equation, I have in minus 4 pi, which means that I am moving this function to the right 4 pi. And then the last thing I need to identify is the vertical shift. That would be whatever is being added or subtracted to that trig function. So that would be outside of the trig function. In this case, there's nothing. So there is no no vertical shift. So now when I go ahead and graph this, since I'm not moving it up or down any, when I go to graph this, I can still go ahead then and just center it at the 0. So we'll just go ahead and graph our graph like that. So the amplitude is 2, so I do want to make sure that I go up 2 and down 2. So I'm just going to kind of space out my 2. So there's 2. And there's negative 2. And now I've got to get those 5 key points in. So there would be my first 5 key points, because remember, first one would be at 0, 0, and then going out to whatever the period is, in this case 4 pi. So that would be, if it just said, so that's what I'm going to graph first, y equals 2 sine of 1/2 x. So if I forgot that that horizontal shift of right 4 pi, if I left that out of the equation, and I just wanted to graph y equals 2 sine of 1/2 x, so like we did in 10.1. That's what I'm looking at first. Once I get those points, then I can move them all to the right 4 pi. So if I went to graph this now, it's a sine curve. So we would start at 0, 0. So I'm going to put a dot at 0, 0. It's kind of hard to see since it's the same color. Then we would have went up to our amplitude, back down to 0, 0, down to our minimum, and then back up to our center line. I'm going to go ahead and just switch the colors out here just so you can see them better. So at 0, 0, up to the maximum, back down to that center line, down to the minimum, and then back up to that center line. So then I would connect those, and that would be my graph. But now they actually want us to add 4 pi to this. So I want to take and add the 4 pi, so that means to the right. So I need to go, oops, let's just say take this function and move it to the right 4 pi. So each of those points, the points I have in red, I'm going to shift to the right 4 pi. So which means I need to get a few more marks on my graph. And now it just worked out very nicely that if this was 4 pi where my last dot is at, the middle would have been 2 pi. So then the first one would have been at pi, and the third one would have been at 3 pi. So they're just going up by a pi. So the next one is at 5 pi, 6 pi, 7 pi, 8 pi, 9 pi, and so on. So now when I take those red points and shift them, so I'm going to shift them all 4 pi to the right. So if that first one, it was at 0, so if I shift it, or I add 4 pi to it, then that's going to put me now in the exact same spot that that last point was at. The next point that was at pi, it's up at 2, but if I shift it over 4 pi, puts it about right there. So it puts it now at 5 pi. The next point, which was at the center line, if I add 4 pi to it, puts it at 6 pi. The one down at -2, if I add 4 pi to it, puts it over at 7 pi. And then that last point, which got covered up by the first point again, was at 4 pi, but shifting it over puts it at 8 pi. So now what I can do is go ahead and connect those. And when I do, let's try to make it as curved as possible, I get a graph that looks something like this. And that's my first cycle that got shifted over to the right 4 pi.